Alright, as promised, here's a video on graphing linear inequalities. So, the last video was just when we had like x is less than 5, and we graphed those on the number line. Now what we've got, something like y is less than 1/2 x minus 1. So what's new here is the fact that it's an inequality. We've graphed equations before, and we're going to do a lot of it the same way. So I gave you a step-by-step version of how to do that with our notes in class, but just in case you forgot, first step was just to find the y-intercept, or the starting value, which is the same thing. So the starting value for this inequality is -1. So we're going to go on the y-axis to -1, we're going to put a dot there. So there's our first point. Alright? And so we're basically just graphing this as if it's an equation. So we got to look at the slope next, which is right here. And the slope says 1/2, so that means we're going to do rise over run. So we're going to go up or down before we go right. So up 1 and then over 2 because it's 1/2. So up 1 over 2, there's our next point. Alright? And then I'm going to repeat this process. So I'm going to go up 1 over 2 from here. And I just made a makeshift on this board. I don't have grid or graph paper on the board, but you will when you do your work. So up 1 over 2 again. Let's see if I get this right. That looks about right. And then since I know the pattern, I could go down 1 and to the left 2 as well. So I could figure that out. Hopefully that's kind of in line. Let's hope. Alright, from here, once you've made all your dots, what you used to do is just draw a line and you were done. But this says y is less than 1/2 x minus 1. So this is not an equation, it's an inequality. So with this less than symbol, you need to look at this first. If it is less than or a greater than, then you need to draw a dotted line. So less than or greater than, strictly, it's a dotted line. If it is less than or equal to, it's going to be a solid line. Or if it's greater than or equal to, it's a solid line. So it has nothing to do with the actual, whether it's less or greater. It has to do with whether it's strictly less than or strictly greater than. So there's no equal to, it's a dotted line. So I'm going to, hopefully my dots are in line here. So I'm going to try to make a dotted line. It looks like that's about right. Alright, dotted, and then I'm going to put arrows on the end, because it goes on forever. And then the last thing, just like we were shading before when it was just x is less than something, we've got a whole thing, so we're going to have to shade a whole region here, because this is two number lines together. So we're looking for all the values where y is less than 1/2 x minus 1. So here's 1/2 x minus 1. We want to do less than, so that's going to be below the graph. So graph everything below this. I say graph it, shade everything below this. So I'm just lightly shading here. If you had a pencil, you could shade it in, and I always shade pretty lightly. Now, when you're looking for solutions for this, what you're looking for are any points inside the shaded region. So this is your solution set. Any point in here, so any coordinate, any x, y. So like, for example, 3, -2 is a point in our shaded area, and that is a solution to this inequality. So, if I were to up the ante a little bit, what I would do is I'd say, okay, well that's great for just one, but if I add another one, I can add another inequality, and I'm going to make this one a little different. Y is greater than or equal to, so let's see, what should be greater than or equal to? How about -x minus 2, let's say. Alright, so I'm going to do this one now. So now that's a system of inequalities, which was the second thing that we did. So this is the first part. Alright, so if I add this part, I'm going to do this. I'm going to graph the first one just like this. Then I graph the second one with the same method. So I'll start with my y-intercept. I'll find -2, put a dot. Then, figure out what my slope is. It says -x. So, it's down 1 and over 1. It's a negative slope, so you know it's got to go down. And it's just an x, so it's really -1x. So that means -1 over 1. So I'm going to go down one and over one. And if I can do this correctly again, hopefully it'll look nice. Down one, over one, down one. Let's see, am I in line here? Close. Something like that. Okay, so I keep going, and then I can go up one and over to the left one. I can do that process. And then I need to figure out, okay, is it a dotted line like before, or is it a solid line? Well, it's got the equal to sign, so that means it's a solid line. So when I draw my line, it's a solid one, which is what we're kind of used to doing. And hopefully it should look like something like this. All right, solid line, arrows on the end. And then last step, figure out where to shade. It says greater than or equal to, so that means I need to shade above the line, which, if I'm shading above this line, I ignore everything else that I've previously done, just look at this line, just shade above it. So I'm going to shade above it, like this. At this point it looks like a hot mess because I've got all this black marker all over the place, but when you're doing this and you're shading lighter, it'll show up easier. The overlap is where your solution is, because for just this line, we've got everything here. For just that line, we've got everything below. So the overlap is in here, so it's everything in here, which now, it's looking really crazy. That's okay. But everything in here, so like there's this, comes to a point here, and everything out there, because it goes on for everything. So I have all the overlap. So not a point out here, not a point out here, but everything here is a solution to this system. So we can pick points in here, and again, like 1, 2, 3, 4, -2, let's say. All right, so if you wanted to check to make sure that those are correct, what you would do, let's say we had a point, a solution would be 4, -2. What you would do is you'd plug in this x and this y, each individually into each one of these inequalities. So like for this first one, if you were to test this point, you'd plug in -2 and see if that's less than 1/2 times x minus 1. And make sure that's right. So 1/2 times 4 is 2, minus 1. Is -2 less than 2 minus 1, which is 1? Is this true? If it's true, that's good. But you have to check it for the other one too. So then you go back to this one, and you check the same point in the other inequality. -2, is it greater than or equal to -4 minus 2? All right? So you're wondering where I got, it was -x, so -4. So is -2 greater than or equal to -2 minus 2? -4 minus 2 is -6. -2 is greater than or equal to -6. So this one works. They work for both of them, so it is a solution to the system of inequalities. If I went too quickly, you can rewind. So, the last thing that we did in this chapter was we did the line, but then we added a curve to it. So if you need to go back and look at how to do quadratic graphing, it's the same process. Shading is the same way. Hopefully that helps.